Okay. So it's 4:05, and so today is November 4th, and yeah, we are sort of off of this. The subjects you see here are not the ones we'll be taking. They've been rearranged a little bit. So you should have gotten your assignment threes done this weekend. Tutorial 7 is due technically this Saturday, but I think I'm going to allow you to submit a week late, simply because 8 and 9 and 10, I think, are all going to be pushed back 1 week, because, well, technically, I have two tutorials that are unit tests for assignment 4. And so it makes sense that they, after, um, or sorry, assignment 5, and it makes sense that they come after you guys have, are done with assignment 4. So there's going to be like just over the next 2 weeks, only one tutorial due. And then, yeah. Um, so assignment 4 is out, and it's multiple inheritance and templates, which we're going to take today, and a little bit of passing functions, which I don't think is particularly hard, but we will take that probably this week as well. And yeah, so the reason I moved templates up, because I'm, and probably you guys are too, like, we make a lot of list classes, and instead of making 3 individual list classes, when we want to store 3 different things, we could just have one templated class, and that's going to work great. So yeah, anyway. Yeah, I decided not to go with UML for assignment 4. So, I mean, technically that means you haven't seen, or you haven't done a UML with inheritance. So please know that for the final. However, I don't know, I just wanted to focus on other things. That's all. Yeah. All right. Any other questions? Oh yeah. Your midterm. So the so we ran into a little bit of trouble, and so we are trying to get that done. It's like 95% of the way there. We are just having to lean on a couple of TAs. Speaking of which, if you have any issues with your marking, please do contact your TAs. I forget whether the course outline says you have 1 week or 2, but please make sure you do that. Yeah, all right. So last class we were talking about polymorphism. Ooh, and we had gone into an example of this this battle game where a hero and an orc fight each other. And I believe, if I'm not mistaken, I'm going off memory here, so I mean, I could be wrong, but I think we got to the point where we were ready to add another character, but we just didn't have time. So today we're going to add that next character. But before we get there, let's talk about what we did. We had a little game, or I made a little game, and it was kind of bad design, but who cares, because it works, right? Main thing. And then, well, then we're going to improve the design so that we can do things, modify it, right? Like add another character, for instance. So what we did is we had, well, we had a, do I have the original? Yeah, so we had a UML, something like this. There was a few other things, like a board and a swing class. But this was the main crux of it. I had a hero and an orc, but they shared a lot of attributes. And so I extracted a superclass. And the nice thing about that now is, and also in addition to extracting a superclass, I redesigned this main algorithm for the battle, right? So before it was calling on hero and orc explicitly. Now I generalized it. So now it's calling things like update on a character class, and drawing the character classes to the board and seeing if the character classes hit one another and seeing if they collide. And then we have a little bit of special, hero-centric logic that we implemented using dynamic casting, and that's it. So now our game is ready to accommodate additional classes. So that's what we're going to do. We're going to make a wizard class. Let's just run the game first of all. Looks something like this. So the hero is jumping around, swinging his sword, and the orc is plodding along and trying to stab the hero, well, the hero wins this time. Okay, so now we want a wizard on this board. Okay, so what we're going to do, well, very simple, wizard.h, oops. So the idea was that now this should be an easy adjustment to make. So we're going to take the orc code and apply it to our wizard. And just like that, we have a very good start. We also need wizard.cc. And we're going to steal some of our orc code again. Right, so the idea now, because we have this inheritance hierarchy, the nice thing is that I don't have to specify every single thing about the wizard, right? So the character class does a lot of this work for me. I only have to specify the parts of the wizard that are different. So here I'm going to give them a health of 10. They're a wizard. They're a little bit weak. I'm going to give them a starting place here and a W for an avatar. And yeah, so this is good. I want them to move like an orc. So this is good. This is the orc move. But I also want them to throw a fireball, which randomly lands somewhere. So we're going to steal some of the hero logic as well in order to, and the swing is, of course, simply, it's almost like a struct that just contains the information that's associated with this person's attack. So this is going to be the fireball. It's going to be 5 wide. It's going to do, what is it, 10 damage, let's say. And it's going to just be randomly, what happened? Oh yeah, sorry, I copied the wrong code. I want this code. So this is the position of the fireball randomly selected from somewhere on the board. So that's the, oh, did I just totally do the wrong place? Yeah, that's what happened. Sorry about that. Okay, so here's where I want it to be. Int fireball. Actually, do I have that? Yeah, so equals a random place on the board. And then this is my fireball, and this is, so the left position will be where the fireball is, and the right position will be fireball plus 4. Okay. And that should be it, except for this, right? Okay, and that's what object-oriented programming gives us, is that a lot of the work is done for us. We just decide what we want to have that's original. Okay, now in our, we're not quite done. We have a new class that should work. So we're going to make sure that we add this when we initialize. And yeah, compiler doesn't know what we're talking about, so we will tell it. And that should seamlessly integrate into our new logic. The last place we need to modify is the makefile. So we want to add a wizard. Here. Okay, and now the moment of truth. Of course, something's wrong. Int direction out, because I messed something up earlier. See if I remember how to fix that. Okay, so I got the hero logic here. Jeez, yeah, I really messed that up pretty good. All right, let me just copy this. Right. So yeah, adding a new class is easy, minus all of the mistakes that you made. And there we go. E7, and I have a wizard that's shuffling across the board and zapping people with his fireball, and just like that. So well, the orc gets beat up pretty bad. I guess the hero wins this one. And stab the wizard. But yeah, and then I could, add other classes or have like a tournament, or, I've set myself up now so that I can modify this easily. Okay. Question? Okay. And that's, I mean, not the only thing wrong with this. Where I look, I think here, right? There's lots of stuff that I'm doing that could be improved. For instance, this is not, this is a different place, right? This is the curses implementation, but you can see here that, I mean, really, this is the double for loop that checks to see if each character hits any other character. As long as I'm not hitting myself, I check to see if they're dead. And then if they're not dead, I see if this character gets hit by this character's swing. And the problem with this piece of code, it's not that, I mean, it works, but I'm exposing a lot of details here, right? So I have to call this isDead function. I call the get hit, which is fine, and I have to call this get swing. So I have a lot of details here that if I do change how this game operates, now I have to go back to anywhere where one player is swinging at another and I have to change all the code there. And I want to kind of localize these changes. So it would make more sense to, for instance, do something like this. Simple, charge I, get hit, charge J. Right, so did this character get hit by this other character? And then inside this get hit function, I could ask if they're dead, right? And if they're dead, I'll just return. I say, nope, nobody got hit here. And also I can get the swing, which means that basically I'm going to hide all of those details, right? That's sort of, that's a good thing, because now when I want to change how this is implemented, I have only one place to do it, in the get hit function. I don't have to go everywhere where I call the get hit function and modify all the code there, right? So that would be a better design, right? So again, I just, just to get it up and running, I did all kinds of stuff that was sort of poor design choices, but that's not a bad thing necessarily, as long as it starts by, as long as it's working. Okay, so that's the end of polymorphism, at least briefly. We'll come back to it, I'm sure. We're going to talk about templates. And what is a template? Well, a template is what you write if you get sick of writing all kinds of list classes in your code. There's two main types of templates. There are function templates and class templates. And well, function templates and class templates are in some sense both like generics in Java, but Java doesn't have any global functions. So we only think of class templates when we think of Java. And then we probably talk a little bit about the vector class. I'm not sure. I might move that to operator overloading, but we'll see. So some of the principles of object-oriented design, some of the things that we're emphasizing: abstraction, encapsulation. But data abstraction in particular, we want to write really abstract code, like general, right? I want to just write a for loop. The get hit is a good example of that. I don't want to specify too much about that. I just want to say, well, there's one character swinging at another. What does that mean? I don't know. It's in the function. Like, I just want to write a general algorithm that the characters walk around and swing weapons at each other. And that's all I need to know, and I can implement everything else kind of behind the scenes. So we're going to continue with that theme with templates. The other theme that we're talking about is code reuse, right? Again, we write a function, we want to be able to call it from multiple places. We want it to be useful in multiple places. And so one of the ways we can do that through templates. Because the template now, my function, doesn't just work on like one type, it can work on a bunch of types. Yeah, mechanisms for code reuse, use existing libraries. I mean, that's a good idea. So the standard template library is, of course, made of templates. So we're going to learn something about that. But the nice thing about these libraries that have been around forever is that people have banged on them and found all the bugs and corrected them. So you can be pretty sure that they work well. And that's a nice thing when you write, well, I don't want to say, it's not too general. It is general. Like these are collection classes that are widely used. But yeah, they are very focused on being collection classes. So the other mechanism for reuse is template programming. So we're going to write a general algorithm that can be applied to multiple data types. Essentially, yeah, we're going to have some type, let's say T or V or whatever. And then when I compile it, the compiler is going to replace that with a actual type that works. And it's going to try and compile it and see if it compiles. So in Java, there's a whole bunch of rules surrounding templates, or not templates, but generics in Java, same thing. Right, and it's specific. I mean, that's the thing about Java is that the answer to every question is, well, how did they implement it? So now you got to read the documentation. For C++, it's usually the answer to every question is like, what's the dumbest thing you can do, really? They do that on purpose. They don't want to do clever things. They don't want to take your choices away from you. So yeah, basically generic template programming in C++ is as low level as you can think. So what we're going to do is we're going to write a template. A template is something that establishes a pattern or establishes or serves as a pattern. So we're just going to write a general algorithm, but it's not going to be an actual, so it's not going to be an actual function or class. It's going to be a template for a function or a class. And then we're going to take that template. The compiler is going to see if this template can be used for the thing we're trying to use it for. And if it can, then it's going to compile it for us. And if it can't, we're going to get some kind of error. So again, our goal, write an algorithm, reuse it on different data types. And our approach is that our data type is now going to be a parameter, but a parameter to the compiler in some sense. All right, so we'll start with function templates, and we will talk about, well, let's see what happens when we try and make a template. So we're going to, oops. We're going to start by opening the correct folder. And moving over there as well. Okay. All right. So here we have, well, just a little program. We have forward referenced or forward declared a function that we're going to implement a little bit later. Basically, it takes 3 integers and returns the maximum of them, right, as a return value. And here's the implementation down here. It's nothing too complicated. I take in 3 values. I assume that the first value is the maximum, but then I just check, right? I say, well, is V2 greater than the maximum thing I've seen so far? And if it is, then I assign it to that max value. And then I ask, well, is V3 even bigger than it so far? And if the answer is yes, then I assign that to max value. And then I just return whatever was assigned. Okay? So very simple logic. And then I can write stuff, well, since I use a return value, I can embed this in another expression, right? I can embed this in a standard output. So I can say, well, max int of 33, 22, and 44 is, let's see, is 44. So it works. That's great. Maybe now though, a max is, that's a useful function. So maybe I want to be able to use it for floats. If I try to do this, the compiler would probably be nice and convert them for me. Maybe. Would it? Is it really though? No. Okay, it doesn't like it. So I want another function that's going to compare floats. And well, I am, I'm pretty clever with my IDE. I can do a copy and a paste and a find and replace, right? So I just copy that function signature and then I change all of the ints to floats. And then when I come down here, I basically do the same thing. I'm going to take this function signature, I'm going to copy it and paste it. And then I'm going to look at every instance of int and change it to float. And then if I look at the logic, well, the logic all still worked, right? Because, well, all I'm really doing is this greater than and this assignment. And greater than works on floats just as good as it works on ints. So does the assignment. So I don't really have to change anything else about the logic of this function in order to get it to work. I just did a copy, a paste, because I recognize that the same pattern would be useful for floats. And the max float returns 44.5. It works, which is great. So now maybe I'm, looking at doing something else now. Well, this is just floats again. Maybe I want to do characters. Okay, but now I'm getting tired of this copy and paste and find replace. And also I'm a human being and not a machine and I can make mistakes, right? So maybe sometime when I copy and paste this, I forget a line or something, and now there's an error in my code. But as it turns out, I'm not very good at doing that. I make a lot of mistakes, but your compiler is excellent at doing that, right? So instead of me copying and pasting it every time I need a new type, I'm going to tell the compiler to do that for me. So what I'm going to do is I'm just going to say, this is a template, right? So using a type name T, this is a template declaration, and then I'm going to take all of these and change them to T, right? So I'm using the same pattern that I had for the int and the float, except T now takes the place of both of those. And then I'm going to go down here, and I'm going to say, well, now the implementation, I'm also going to say is a template. I'm going to do similar to what I did before. I'm going to take all of these ints, but instead of replacing them with floats, I'm going to replace them with T. And then we can get rid of this guy. Okay, so now I have simply one declaration, one implementation. They have the same pattern as before. And well, let's see what happens here. If I run it now, it runs with ints, it runs with floats, and it runs with characters even. Right, so it said Z is return the greatest of these characters, capital Z, or small c. Did I return the small one? Yeah, I guess the capital comes before, yeah. So, right, and that works because, well, if I look at this greater than, right? So, well, let's talk about what the compiler did first of all. So what the compiler did is I said, well, here's a template. This is not a function, right? If I compiled this without calling max, I don't get a max function. But here I'm going to call max, and the compiler is going to look for a function that matches this signature. And what it's going to find is it doesn't have a function, but it does have a template, right? In particular, it has a template that takes three types as arguments and has the name max. So that fits this pattern. So then the compiler is going to do exactly what we did. It's going to say, well, this is the pattern. So I'm just going to copy and paste this. Oops. Go away. Copy and paste this, and then just do a find replace on all of these, right? I need it for ints, so I'm going to do that. And that's okay. Well, nothing. I mean, this is just a declaration, so this is not the important part. And then it comes down here and it does the exact same thing. It says, well, I have a template that matches that pattern. I need an implementation, so I'm going to copy and paste it. And then I'm going to do find replace. And so I called it with an int. And so the compiler is going to take this template, copy, paste, find, replace, and then it's going to try and compile this. And it's not going to get any compilation errors because the greater than function works on an int. And so does the assignment operator. Okay, so, and of course, the compiler, is not going to make mistakes when it does this. And then, okay, so that's great. So it works for ints. And then I call it again with floats. Well, again, it's going to look for a max function and it's not going to find it in this case. So it's going to say that, well, I do have a template that matches this pattern. And again, it's going to do a copy, paste, find, replace, but now with floats. And then it's going to come down here and see, well, again, I have this max function and, well, copy, paste, find, replace with characters. And as it turns out, well, the greater than operator works with characters as well, right? It's going to just compare their ASCII values. And yeah, so the big Z comes before little z in ASCII. And that's basically all it does. It's very, very primitive. So in this case, when I compiled this, I got 3 functions. I got function max that worked on ints. I got a function that worked on floats and a function that worked on characters. I don't get any other functions, right? And they are separate functions. So it's not like it's not like magic. It's really just what you would do if you were faced with the same problem. You're just going to copy and paste and find replace on it. All right, questions? Okay, and then, well, let's see. What if we did something like this? I also have this time object here. Oh yeah, never mind. Well, we'll get to this in a bit. But otherwise, it just contains hours, minutes, and seconds. And this is technically like a print function. Right? We're going to get to that when we get to operator overloading. So nothing too complicated, but it's a type that we made. And so what I can do now is say, well, I can call this max function with 3 time objects, right? Because all the compiler is doing is pattern matching. So then if I try and do that, oh, well, get a bunch of errors. And why did I get a bunch of errors? Well, if I go back here and when the compiler did copy, paste, copy, paste, find, replace with T with time, it turns out it doesn't compile, right? And it doesn't compile because of this line here. And this line, of course, but, right? So there's no greater than operator for our time class. Can be, we can make one for it in C++. When we get to operator overloading, we will. But currently, there's not. So will this work with my type? That depends on really just, I copy, paste, find, replace, try and compile it. And will it compile? Yes, then yes, it does work. If it doesn't compile, then I guess you got to fix it or do something else. All right, questions? Yeah. The difference, so the only difference is primitives can use this greater than operator. The Booleans, can they use the greater than? Maybe not Booleans. But yeah, so floats for sure, characters, like and all the longs and double like that. Yeah. But also like, I mean, not to give anything away, but I can do something like this. Whoops. Right. Oh, Like now I have an operator that works on the time class. I don't know that it doesn't work correctly. But here I've just implemented this. Yeah, so the only change is, does it compile? That's it. The compiler doesn't care about whether it's a primitive or a data type that you made or something from the library. It's just pattern matching and compiling. That's it. All right. Other questions? Okay. See if I yeah. All right. So again, just to review, consider a function that looks like this. We want to do the same thing for floats and maybe some other, characters and things like that. Well, we can just make it a template. Oh yeah, there are a couple other things I wanted to mention. So you might notice here that I used the keyword class, and up here that I used the keyword type name. I prefer class. In terms of declaring your templates, there is no difference. Okay, so it doesn't matter if you use type name or class. I like class, well, just because it's shorter, it's easier to type. But yeah, both are perfectly correct. There is a difference between the class and the type name keywords, which we'll kind of cover a little bit up soon. But they are interchangeable in this case. The other thing is that I'm using capital T here. Oops, sorry. I'm forgetting my, right? I can use capital V, right? Again, that's, no, what did I do? Oh yeah, I have one more V here. Oops. Shift V. There we go. Right, so the fact that I used T up here and a V down here, that's totally fine, right? Again, all the compiler is doing is copy, paste, find, replace. So it doesn't matter if it's replacing the T or the V. I can actually also, oh, oops. I can also use words if I like. By convention, they are usually capitalized, but technically I can use any kind of placeholder I want here, and it will all still work. Okay. All right, questions? Okay. So yeah, what do we do for a function template? We write a function with a type marker, in this case T, and then we call the function using any type, right? And then that type is passed in as a parameter when we compile, and the compiler will try and make a version of that function for that type. And right in the example that we just did, we had 4 different types. We called max with 4 different types, and it made 4 different versions of that function. So every time we add a new type, we get a new version. If we do not call it at all, we don't get any compiled. All right, yeah, and the only thing that we care about whether it will work for a particular type is does it compile? That's it. And otherwise, yeah. So, well, another thing is if I have a template, but maybe I decide, well, I actually want I want a max function that works for ints, but I want it to work slightly differently. I want it to have a message when I'm doing ints. Right, so okay, so I have a function with the same pattern, right? So takes 3 ints and returns 1. And so if the compiler has a choice between a function that already exists and a function template, then it's going to choose the one that already exists, right? So when we called it on ints, it chose the max function that already existed. It did not make a new function out of that template. Yeah. All right. So function templates are interesting and certainly useful in C++. But of course, the thing that we care about more is class templates. So what we want is to create a class that works with any data type. And again, our class is now going to have a type parameter when it is declared, right? So we'll see what that looks like in a minute. What that means is that this type can be used anywhere in the class, right? I can have a data member, I can have a parameter to a function, I can have a return value, they can all be that type. One of the more useful applications of this is collection classes, right? I want to store a bunch of a thing, and pretty much that's, the things I want to do in a list are kind of universal for many data types. So yeah, if I just write one list, it works for a lot of different data types, and that's great for me. So in this example, we have a book class, nothing special, title, author, ID. This is a book class we've seen before. And here we have a list that stores book pointers. Okay, so it's a list class, and we have this reverse function that's a friend. We will talk about that in a minute. For now, we're going to make a list of books, and then we're going to add these books to our list, and then we are going to print them out. And it's a singly linked list, right? So I want you in your next assignment to make a templated list function, an array-based list, right? So we're going to do the more difficult one here, and you guys will have the easier one to do for your, not that both of these are pretty easy, but you'll have the easier one to do for your assignment. Will it work? Yeah, it works. So my list of books, Ender's Game, Dune, Foundation, blah, blah, blah. Okay, so that works. What I want now is to, well, maybe I want something like this. I want a list of ints. So I want to be able to store integers. So I want to be able to call some code that looked like this. Now this is giving me an error because I'm not allowed to add an int to a list, right? Because it's only book pointers. So I'm going to take this list type and template it so that it can be used for ints. And then we're going to see all the problems that come up as a result. So most of it is pretty easy. So all I want to do for my class is I'm going to say, well, this is now a templated class. Okay, so I have this template declaration for my list class, which means that now anywhere in here where I previously, here where I previously used book star, I want to replace that with T, right? So I was storing book pointers before, but now I want to be able to store anything. So I replace book pointer with T. And here as well, this will be T data. And so that's my class definition. And well, you'll notice that I have the implementation in the same file. So we're going to talk about that in a minute. But first, we're going to fix all of our implementations as well, because now that my class is a template, it's no longer actually a class. And this declaration kind of doesn't make sense. So what we have to tell the compiler is that, well, this implementation is an implementation template. And what class is it an implementation template for? Well, there's no more list class. There is a list T class. Well, it's not really a class even, it's a template. But once we put in a type for this T, then we actually get a class. But we can see this, the compiler has calmed down here. So we're going to make all of our implementations into templates. Again, not too difficult. We just got to keep an eye out for, basically what we want to do is go through all of this, and anywhere we see book pointer, we're going to replace it with T. And anywhere we see list, we're going to replace it with list angle bracket T. And otherwise, the logic should stay the same. There shouldn't be too much change. So book pointer is going to change to T. List becomes a list of T's. And I think that should be fine. If there's any mistakes, I'm sure the compiler will let us know. The add, okay, so now this book star becomes just T, and then this we'll make it little t. So we'll place this book with little t, and that's it for add. Remove. Okay, so we're sort of doing the opposite of what the compiler is going to do when we supply a value, right? So when we make a list class with a book pointer, it's going to go through and change all these t's into book pointer, the opposite of what we're doing now. I'm going to return a t here. I think one of these causes a problem, if I'm not mistaken. That's fine. Okay, so that's it. Our list class is template. Hopefully, like fingers crossed. We'll see what goes wrong. But now our list class should be able to be used with any type. We will start with the book star type. Right, so that is I didn't change any of the logic, so this should behave exactly the same. We will comment that out for now. Oh, this reverse, yes. We will come back to this. And we will comment that out as well. Right? It's just a little bit too much trouble for the moment. Okay, so we just have a simple linked list of book pointers. And yeah, it works exactly the same as before. And let's see if it works now with ints. So maybe I could do something like this. Int. I'm going to add all of those, and then maybe, oh, this doesn't work, but all right. All right. This going to work, do we think? Big test, right? Okay. The answer is no. So why is that? Well, we want now a general list class that works on, first of all, anybody see where the problem is? I mean, this might give you a hint, I guess. We made an assumption about, the problem is when we went back and changed all this, we made an assumption about the types, the data types that we're going to store, right? And in particular, this line here is the problem. This data, well, this is of type T. And here I assumed that it had a print function, right? So if I go back here into my prints, it goes through and it looks at every piece of data and calls print on it. And as it turns out, ints don't have a print function, right? So when I'm trying to generalize my list class here by making it a template, I have to be careful not to make any of these assumptions, or not too many of these assumptions, right? Maybe I want to restrict it to a certain, like a few classes. And if that's the case, then I can do this. But in this case, this is not really what I wanted to have happen. So what I'm going to do is this. This is sort of more general. A lot of different data types override this cout, the stream insertion operation, right? The angle brackets, the two left angle brackets here. This is sort of standard. So this would work on a wider variety of data types. It's a little more general. And then, oh, well, It does work on a wider variety of data types, but it turns out book pointers, they get memory addresses now instead of books, right? So templates, right? The cost of writing general code is that I do not get this specific code. I cannot write a print function that really kind of works for everything. Yeah. Questions? Okay. So that's one danger. The other danger here is, well, let's go back to this reverse operation. Sorry, here. So I have a friend. My friend is this reverse function. And well, I think even just compiling this now, it's going to give me a warning. It says this declaration declares a non-template function, right? So I'm calling a function on what appears to be the list class, and the compiler saying, like, you sure you really meant the list class, or did you mean list T? Right? Because now there is no list class, there's only a templated list class. And really, I want my reverse function to work for every type, so I'm going to make this a template as well. Right? So even we talked about before, when I declare a friend function, a weak forward reference. Like I'm declaring that this function is a friend, but I'm also saying like this function exists. Right? So this is information for the compiler, and the compiler actually needs to know, is this actually a function or is it also a template? To give it this template declaration. There is one more problem. It says declaration of template parameter T shadows template parameter T, right? So similar to when I declare variables, this type T, each variable has its own scope, and I can, if I have two variables with the same name in different scopes, one will shadow the other, which means I render the other one invisible, which means this template declaration is going to hide this template declaration. So when I'm in a situation where I have a friend function that I'm forward referencing in my class, I have to use a different variable name, right? So then V here does not interfere with this T, and then it should be able to compile, although it might complain. Yeah. Well, we didn't call it, so it's not complaining that there's no implementation, but all right, questions? Okay. Let's implement it then. Well, this is okay, so we got a bunch of stuff going wrong. This is a global function that is a template. List does not exist anymore. List T does exist. And then, well, we seem to have no more flaring red. So let's see if that'll work. And the answer is no. Right? And why doesn't it work? Well, that's complicated. But remember when we talked about how type name and class do have different applications? This is one of them. So sometimes the compiler gets confused with templates because, well, actually, first of all, I should fix this. And then we still have these errors. The compiler gets confused here. Why? I mean, it'd be hard pressed to be able to reproduce this example. I stumbled across it by accident. But what can happen, apparently, if you read enough Stack Overflow pages, is that for some reason the compiler gets confused. It doesn't know if I'm declaring a type here of node pointer, right? It doesn't know what a node is somehow. I don't know. So it's not sure if I'm saying I want to multiply these two things together, or if this is a node pointer variable called current node. So I'm going to give it a hand. I want to say that this is not a variable. This is a type. Well, I'm going to say type name. And again, if you have questions, I'm not 100% sure I'm the best person to answer them. However, if you ever come across that, right, this sort of error, with templates, it could be that your compiler is confused and you need to tell it that it's a type name, at which point everything works. And then I'm assuming this reverse code would work. I haven't tested it. Yeah. Questions? Yeah. It's a lot of detail. You don't have to memorize how to fix this or why it would occur, but just if you ever stumble across it, maybe, somewhere in the back of your mind, you'll think, oh, maybe I'll try type name, and maybe that's the solution. All right. So, yeah. So when we generalize, we have to be careful about the assumptions that we make about the data types being used. Do we really want to assume that they have a print function, right? That's something we need to consider. But otherwise, yeah, we just made it a templated type class. Oh, yes. Thank you for reminding me. Yes, I did. So everything is, and this is how we expect you to write your list class as well for next assignment, right? So the piece of code I gave you, everything is in one file. Everything's in the header. And you should keep it that way when you template it. The reason being, well, let's say that I split them up into, let's say that I split them up into header and source. Okay, so now I'm going to do something like, well, I want to compile it into an object file. Okay, so this is going to, but wait. So the compiler can't compile this until it knows what type I need. And if I just compile this alone into an object file, it's a template. It says type T. And the compiler doesn't know what a type T is, right? So there's not enough information here for the compiler to do that. And if you try that, you'll get a warning. It'll say like, I cannot link to this. And maybe it'll say something about types. So I don't know. But yeah, essentially, it doesn't know what T is. It can't compile it. So if I put everything, there's a couple solutions to that. But the easiest one, and the one that I would encourage you to do, although, feel free to experiment if you like, you just put the implementation and the header together. And then, in my main function, okay, so while the compiler, when it's compiling it, it says, oh, list.h, it goes through, it finds the implementation, or it finds the declaration and the implementation of my list class. And then it comes down here and says, oh, they want me to make a list of books, a list of book pointers. So then it'll take all that implementation and declaration, do a copy paste, find, replace, and compile it. And if it compiles, then I have a brand new class here, right? And if it doesn't, of course, you gotta debug. And then it can do the same thing down here, right? So yeah, that's another thing about these is that my list class of book pointers and my list class of int, those are two different classes, right? The compiler generates two classes here. Same as with my function where it made multiple versions of the function. It makes multiple versions of this template, right? So it makes multiple classes. All right. Questions? Am I forgetting anything else? Okay. All right. And the other thing, of course, if I declare a friend function and that friend function is also templated, like this doesn't have to be templated, eh? I could do something like, right? If I wanted to, I could just say, well, I only want to reverse lists of ints. Like that's okay. And then I would take this away. I have to have some value here. And if it's a generic, if it's a placeholder value, then it has to be declared as a template. But I am free to actually put regular types in there if I like. Okay. Yeah, the difference between class and type name, no difference here. We did see where we had to use the type name here as a compiler hint, right, to make sure that it compiles correctly. And again, if I try to reproduce it, I would have trouble. I don't really understand how that's ambiguous to the compiler. I've given it some thought, but there is Stack Overflow posts. There are smarter people than me on the internet who do have answers. How we implement a class template. Well, we simply declare a class and we substitute a type key variable, and then the compiler does the rest. So I declare an instance of the class using any data type. The compiler does the copy, paste, find, replace, and tries to compile that class. And if it compiles, you're good to go. You have a new class that you can use. If it doesn't compile, then you have problems. Incidentally, it only compiles the functions that you call on that class, right? So that is, right, that print for ints didn't show up until I, right? If I had, well, too late now, but that's one of the dangers of templates is that you can have these ticking time bombs, right? So if I don't call a function, it doesn't get compiled. And maybe if I called that function, it would be an error, right? So maybe I have a template that works great for this type until one day I decide to call reverse on it or whatever. And then all of a sudden my code breaks because in the reverse function, I make some assumption, right, that I call some function that doesn't actually get implemented. So you do have to be careful of stuff like that. Okay. Special cases of class templates, multiple types, non-type parameters, and default types. So that is the basic of templates. Collection. Explore a couple things further. So here I have a map item class, right? Very simple. I have a key value pair. If you use dictionaries in Python, you've seen key value pairs, or in Java. And then I make an array of these map items, and then I store a bunch of hockey player names in them, and then I print them out. So what we're going to do is we're just going to make this map item into a templated type, and we're going to explore a couple of further scenarios of the things that we can and cannot do with templates. So yeah, untemplated type works fine. Maybe though I want to, well, it's a map item. I want to store some grades for students, right? So I want to be able to map students string names to some grade point average. Okay, so I'm going to make this into a template. Class K, class V, right? So now there are two types, and I can use either one of them. So I'm going to use key and value here, and key and value here. And right now the implementations, also templates. Not only that, there's no such thing as a map item anymore. There is just this templated version of a map item. All right, print is implemented up here. Okay, great. So, well, that wasn't too hard. But now when I declare this, I have to say, well, int string. And then this should work exactly the same as before, as the compiler just goes through and copies and pastes, replaces K with int and V with string, and I get the exact same code as before. But now also I can use it to store GPAs for students. And so I can make an array of these things and store all of these students and their grades and print those out as well, right? And the key is basically, well, if I compile it with a string and a float, it also works the same as if I compile it with an int and a string. All right, questions? Okay. So here we're going to take this map item. We're going to, did I really leave that, a print function? No, I got a print. Okay, so that's, that should be okay. Okay. I got a map item and I got a map that stores map items. Right, so I'm going to have this templated type inside of my map. So my map item. Whoops, and I want this. Let's give it a. We'll give it a maximum of 10. And then int num items. And oops, yeah, size, I mean. Right, so it sets size equal to 0 up here, and inside my map, I'm just going to sort of abstract away the details. So my map contains a array of these things, and then I can add or print. The add, if size is greater than or equal to max, then there's no more room. Otherwise, items at size plus plus, let's set key value. And then print, yeah. Okay, so oh, we're not quite there. We're getting there. I changed it to map because I was getting very confused about for some reason I become like dyslexic between my map and map item. But yeah, I can. All right, so now I have a map. I can add, it's going to function pretty much the same as before, but now it's stored in a class. Right. For some reason. I carry this tiny mistake forward from semester to semester. Redeclaration of size. Where did I do that? Oh, I sure did, didn't I? Okay. All right. So now it works as before. Okay. So um, I stored this, I have a templated type inside of my map. But now also maybe I want my map to be templated, right? That would sort of make sense. So I'm going to, oops, class K. I'm going to have a templated type within a templated type. And whereas before we were sort of worried about, not hiding K and the V. Well, in this case, I want to reuse K and V, right? Because again, I want it to work if the compiler copies and pastes this and does a find replace K and V with int and string, then I want this to work the same as it did before. And so using that as my guide, I think, well, if I replace this with int and string, that is sort of the behavior that I want. And then I'm going to fix these. Oh yeah, and this also has to be K. Okay. Easy peasy. Yeah. So the main lesson is I can have a templated type within a templated type, and then I can reuse K and V inside my templated type within my templated type. And then I simply make this an int and a string. And then I can add my hockey players as before, and everything should work just fine. Okay. All right. Questions? Okay. Maybe though, of course, every time I make this, I have to figure out, right? So if I made it size, here I used 10, but let's say I did 5. It's possible that I add too many, or maybe I should have made it 4. Regardless, it's possible that I add too many. So maybe when I make a map, I want to actually tell that map how big I want it to be made, right? I kind of want that hard-coded, and maybe for whatever reason, I don't want to pass it in as a parameter to the map class. What I really want is to pass it in as a parameter to my template. So what I'm going to do is say int capacity, right? So as it turns out, I don't have to just declare types. These abstract types of K and V don't have to be just classes. I could actually make them an int or a string or whatever I like. And I can assign them values. So yeah, so instead of, well, this is still the same, right? I only need K and V here. This now is going to be int C, and my declaration of map now must include this third parameter. And instead of size greater than or equal to max, I'm just going to use this this type from my template declaration, right? So when I pass in this, when I make a new map class, I'm going to pass in this value, and the compiler is going to come through and replace all instances of C with whatever value I put in there. And then this here also capacity. Yeah, I need to see here. Okay, and so now I can say, well, I want, let's say I only want 4 people, right? I want a map that holds 4 people, and then I go, and it holds 4 people, and if I try to add a 5th person, well, then it should cause me some trouble. And it says no more room, and it exits. So now I can define sort of dynamically at runtime, or well, it's still at compile time, sorry. At compile time, I'm going to say how many of these, right? I'm going to give a value to this integer. All right, questions? Okay, so what are some of the implications of that? Well, one of the implications is as follows. I've declared here a static variable cap, right? And so what I'm going to do, I want to actually initialize this static variable as a template. I want to initialize it using the capacity, just to show you something. Well, static variables, as we know, have to be initialized at file scope, so I have to declare it is a template of an initialization, right? And this is int cap, int map A, comma, V, comma, C, cap equals, and I want to set it to whatever value they passed in. Okay, so yeah, when I'm initializing my static variables, they also have to be templated. But then I can take whatever the user passed in and assign it to this, this value. Okay. One other important thing to note about this, let's say I did this. So I'm going to make a second map function with the exact same parameters. And I'm going to say map cap, right? I'm just going to print out, this is a public static variable. So I'm going to say and I'm going to do the same thing for map2, sorry. And well, they should be the same, but well, let's test that out. No more room. Yes, of course. Instead of using for, would you be able to use an int variable instead? Ooh, that's a very good question. Doubt it, but that's an excellent question. Yeah, the compiler does not like that. There are tricks for doing this in C++. Basically, you have to reassure the compiler that it can figure this out at compile time, right? Because right now it doesn't know, like, even though this is very simple code, but there could be like a million lines between here and here that where I possibly change this value. So it can't at compile time figure out what value to supply. This has to be an R value essentially. If I did this, perhaps this would work. Yeah, it's happy. As long as I can guarantee it, what that number is at compile time, the compiler will be happy. Yeah, great question though. All right. So our two static variables are both 4, which no surprise there. I'm going to set map.cap to 10. And we can see that map2.cap also changed to 10, right? Because this is a class variable. And so there's one instance of it for all of the classes, for this entire class. And as it turns out, this map2 and map1 are of the same class. However, if I change this to a 5 now, maybe I want map2 to be a little bit bigger. Well, I changed map capacity to 10, but this one stayed the same, right? So yes, this is an easy way to pass in value, right? I declare an int in my, just as a type, and then I pass in the value 4 or 5 or whatever. However, if I use a different int, I get a different class, right? The compiler has to go through and for each unique set of types and values, it's going to make a unique class, which maybe I'm okay with, but maybe that's, if I wrote a for loop and I said, well, for loop would be a good example, but if I had a bunch of constants and I tried to make 10 of these things with different values, they would all be different classes, which maybe is not what I want. But yeah, questions? Okay. Of course, you can always declare it using the scope resolution operator because it is a static variable, so I can use the class name itself, which also works. Anyway, like everything in C++, it's a few simple concepts and then like a ton of details that are very tough to remember, but just so you have an idea of what those details are going to be. I think that's it. Yeah, so templated types really are parameters. Oh yeah, there's one more thing, I guess, one more lesson just for the last 5 minutes. So now I have 2 templated types, or one templated type that takes 3 arguments, but this is getting long. Maybe I have a bunch of arguments and I don't want to fill them in every time. So the same as with my function parameters, my template parameters can have default values, right? So I can say, well, by default, if you want to make something larger, you can, but by default, I want the capacity to be 4. And then I don't have to include that value, right? It's going to get filled in for me. And let's get rid of these distractions for now. I'm just going to add some hockey players, print them out. And yeah, that works. And if I try to add a fifth hockey player, it says no more room, right? So by default, I get a size of 4. But if I really want a size of 5, I can specify that I want to have that extra room. And yeah, that doesn't just work for my int. If I go here, make sure I'm in the right place, because like with functions, if I want to have default parameters, I put them in the declaration, not in the implementation, right? So down here, I don't put anything. I just leave this as an int C, and the compiler is going to figure out, the compiler is going to take the value from up here and supply it to the implementations. But up here, I can say like, well, maybe I want this to default to string, and then I can just pass in an int here. So I can have an int, and then by default, the value will be a string, and by default, it will have a size of 4. And well, of course, I can also say, well, I want this to be an int, and then I can just put the angle brackets, right? I can make a map with just the angle brackets. I don't have to put any of the, if they all have default values, I don't have to put any of them in. One last thing is, of course, the same as default parameters or my functions, my default values all have to be to the right? I cannot have a default value here, a the non-default value, and then a default value on the other side of it. The compiler does not like that. So yeah. These really are, in some sense, parameters, but I'm now passing the compiler instead of to a function. So they kind of obey all the same rules as parameters, except, we're also using types and things like that. All right, questions? Okay. All right, one last thing before we go. Covered a lot of stuff today. I know I'm just trying to keep up with the other class. Hopefully not too much detail. I like all the detail about C++, but I know it's a lot when you're sitting for 80 minutes. So one of the things you can do in Java that, I sort of haven't talked about here is that, well, in Java, I can say something like, T extends number, let's say. And then my templated class will only work on things that are numbers or subclass of numbers, right? So I can restrict what things I want to be in my templated class in Java. I can't do this in C++. The only thing you can kind of do that's equivalent in C++, again, because C++ does, the most local thing, it just tries to compile it and says, it compiled, so you're good to go, or it didn't compile, so you're not. But I can make like a dummy function and say, well, I'm going to declare something of this base class, and I'm going to try and make a new T. And right, by our rules of inheritance, if T is not a member, is a base class, right? If T does not inherit from base class in some way, then this will not compile. So you can do this. The drawback is that I do have to call that function for this to work, right? So you're going to call a function, you're going to waste a couple CPU cycles trying to make something. But if you do that, it won't compile unless T is a member of base class. So yeah, that is, there is no, again, C++, there's no rules, you just kind of got to make your own. All right, questions? Okay, so we'll stop there today. One question. Try and catch, yes. We're going to get to exceptions. That's coming near the end of the semester. We're going to do templates, and then we're going to move on to design patterns and a bunch of stuff. But yeah, so that's it for today. I will see you guys on Wednesday.